Hey, everybody. I think at this point I've been able to attend more than half, the majority of. Oh, little closer. Thank you. I think at this point I've been able to attend about half of the ad filtering developer summits that have been produced. And it's really cool to see the evolution of this forum and the discussions that we're having. Unfortunately, I wasn't able to attend last year, but I'm very excited to be able to talk about what we've been doing on Firefox this year, since the last time we had a chance to check in with you all on what's going on. So the structure of this talk is going to focus on two main areas. First, talking about what we've been doing over the past year in Firefox, and time allowing, we'll dig into a couple of specific code examples with Manifest v3 on some cross-browser development patterns, focusing primarily on background contexts and getting things to run everywhere as expected. So let's start with some major changes that we've had over the past year. We're going to dive into all of these in more detail, talking about match origin as fallback, main world content script injection, runtime get contexts, host permission grants, changes in Firefox, and optional host permissions. There's plenty more after this, but these are going to be specifically the Manifest v3 compatibility things that we've been working on. So first up, match origin as fallback. For those that aren't familiar, this is a content script property that allows you to specify the ability to inject your content scripts into subframes of a given page. Previously we had in the pre-MV3 world this concept of all frames true, that allows you to say that I want to inject my content script into subframes in this document, and if the subframe had a matching host permission pattern, like we have matches example.com here, then you would be able to inject into it. But not all subframes are created equal. Not all have a well-known origin that you can easily associate. So match about blank allowed you to target frames that were, say, created without a specific source. The browser still has to give it some content to display. That's by default about blank. There's also a special case source doc. So here we have example.com. We're injecting a script in and it's setting background color. But you can see that we have a couple of frames that aren't being matched. And those are specifically data URIs and blob URLs. So those have their own custom schemes. They're not the set of things that we were previously matching against. And one small caveat, Firefox with match about blank would also match on blob URLs. This was undocumented and inconsistent across browsers. So we've changed that, and that's why you're seeing the behavior here. But that capability, being able to target different frames, different contexts, being able to modify the documents, that's pretty core to what extensions do. So we had before Manifest v3 actually kind of shipped in various browsers, there was collaboration between Chrome and Firefox engineers. Actually, specifically Devlin and Rob, who are in the room with us today, were discussing this issue and how we can improve it. And that got us to the introduction of match origin as fallback. So when we have these unique frames without the ability to associate them with a given domain, rather than just having a increasing number of flags like about blank and doc and data URI and blob URLs, instead we have this general concept of expanding the pattern matching to all of the different subframes. When we need to, we can match on this broader pattern. And that, when we use match origin as fallback, you can see we've matched the injecting contexts origin, and that allows us to inject into all of these different subframes. Next up for Manifest v3 compatibility is the introduction of the ability to target by the injection world. So in the world of content scripts and extensions, we have two main worlds. We have the area that the JavaScript is running in, that the page itself is loaded with, and we have the JavaScript that the extension is injecting. And by default, those are separate contexts that they share the same underlying DOM access. You can modify the content of the document, but your JavaScript can't directly interact with the page's JavaScript. And while that is useful for keeping things separated and limiting fingerprinting, etc., one of the drawbacks is it sometimes can be useful to directly interact with that content. So the way we would do this in Manifest v2 is you would inject a normal content script, and then in that script, you would do something like this. There are a couple different patterns on how you can actually perform this, but this is a common one in the ecosystem. That you create a script element, you assign it some bit of arbitrary code. Here we are in the inject script call, we have a string of content that we're going to inject as the script source, and then we add it to the document. But for security reasons in Manifest v3, we introduced changes to content security policy that limited the ability for scripts to execute whatever code they felt like. While this is powerful and is used well by good actors, it's also highly abused. So one of the things that we've done is it's no longer possible to just append an arbitrary script to a parent document. So we needed a way to address those use cases. And we've done that by introducing the ability to specify a world in the content script declaration. So here, the only change, sorry, I'm noticing my mouth is a bit dry. The main changes that we've made are we've changed the JavaScript that is being injected from content.js to content main. So this is a new file. And the world, we're explicitly saying what the injection context that we're targeting is. And then the content of that file is just that same alert that was previously a string, but now baked into a static file in the manifest. One other thing that I don't have a slide for that I want to call out is this is obviously the static declaration method for content scripts, but we can also do this kind of thing with the scripting API, where you can register a dynamic content script and inject a function and pass that arguments. So you still have the security properties of these static files and the ability to make them dynamic through the passing of arguments. So I think we're trying to find a good balance between what is possible but also safe. And now this works across browsers. This one I'm going to go in significantly less detail on, but another feature that we've collaborated on across browsers is the ability to target your different execution environments. So in particular, UI surfaces that an extension might have. In Manifest v2, we had the concept of runtime.getViews, and getViews were directly associated with views that were rendered for the extension, and also, as a challenge, provided direct synchronous access to those documents across the different environments. So a page could, kind of like an iframe, reach into another page and directly modify it. Conceptually, that is cool. It's also very bad for performance. So we needed a replacement for getViews and something that would enable asynchronous work between these different contexts. And that's where the get contents function comes in. This provides you with references of ways of working across these contexts, but in embracing the asynchronous design of Manifest v3. Host permissions. So one of when Firefox first shipped its support for Manifest v3 in the first public release, actually, Rob, keep me, is that accurate? That we restricted host permissions by default. So an extension can declare its set of hosts that it wants to interact with and have additional privileges on. Thank you to our sponsors. And by default in Firefox, at installation time, we would not grant those. It would require some additional user action, some additional flow implemented by the extension in order to get access to those contexts. that we heard pretty clearly from users and developers alike that wasn't working nearly as well as we wanted. So as a stopgap, we've changed that behavior. We're now granting the requested host permissions by default. We're kind of taking a step back to give us an opportunity to assess and improve the installation flow and permission management experience in Firefox. So we have work on that front coming. I think the direction that we were going of giving users more control over where and how extensions run is still something that we want to pursue. We just realized we missed the mark with our initial implementation. Oh, yes.
Okay. So to add, in Manifest v2, an extension request for the host permissions, it just called it an MV3. An extension can still now get it at install time, but the user always has the choice to toggle it to, well, say no again. Oh, I'm Rob. Rob. Oh, I'm Rob Wolf, Firefox engineer working on web extensions.
Thank you, Rob. Rob is definitely going to join in for our Q&A. We also introduced support for, over the past year, we introduced support for optional host permissions. In collaboration in the web extension community group with the other browser vendors, there was a clear need that when Manifest v3 was initially designed, we were going in the direction of restricting host permissions. And the initial thought was that host permissions would be optional by default. But over time, we realized that we needed a way for extensions to clearly signal which things they expected to need all the time and which things they knew that they would optionally take as an enhancement. So, for example, there are some extensions that run on GitHub, but they also want to run on GitHub Enterprise, which would be hosted internally in your own company. In those cases, you're always going to want access to github.com because that's where you're operating, that's how you work. But you don't know where you would also be needed. So in order to run on those other sites, the only way that you could do that previously was declaring all URLs as your default host permissions. But the extension doesn't want to run everywhere. It only wants to run on GitHub or GitHub Enterprise. So to address that, optional host permissions allows you to say, I want all URLs. I want the user to tell me where they want me to run, and then I will run there. And that's it on GitHub and whatever they tell me to. So this pattern enables that kind of thing. Again, here's a quick rundown of the recap of the main Manifest v3 compatibility things we just called out. There are so many more of those Manifest v3 things. So I just tried to pick what would fit on a single slide and then expand those. Very happy to dig into additional stuff if anybody is interested. For this audience, I also wanted to highlight some declarative net request capabilities. Firefox has a bit of a different stance from Chrome on the role of the web request API. We recognize that that API has a lot of power and capabilities that can't fully be performed in a declarative model, but we also want extensions that are primarily being built with declarative net request in mind to have a first-class experience. So we're continuing to work on our declarative net request. Actually, Rob is continuing to work on the declarative net request implementation in Firefox. And a couple of main things, or a couple of changes that I want to call out on declarative net request are enable disable static DNR rules, domain type rule condition, and some changes to rule management. So first up, oh no, this is session, that's the next thing. So enable disable static rules. I think eyeo championed the work on introducing the ability to control whether or not a given static rule is enabled. And that was introduced in this declarative net request.update static rules method. We now also support that. And so it's possible for ad blockers and filter list maintainers to deploy updates to the statically bundled rule sets and introduce dynamic rules that will also modify the rule sets being executed at runtime. Next up, domain type. This allows a rule to target a first-party request or a third-party request using EasyList semantics. So this should basically work as expected for everybody. And hopefully everything is working as expected there. Yeah. Oh,
So the reason for the domain type implementation to be delayed is because there are multiple ways to consider what is third party or first party. Ultimately, after discussing with some developers of ad blockers, we end up with just the easy list semantics. It's not strictly the same as any other definition of first party or third party in any browser, except the DNR implementation, but it's close enough to what the developers expect from it. Another call missing from the slide is that I optimized part of the DNR implementation based on real-world user feedback. So if you ever use DNR and spot performance issues, please report it to Mozilla. Adoption of DNR for ad blockers has been very modest in Firefox because we still continue to support blocking web requests, which is a more powerful API for ad blockers to use to offer an ad blocking experience.
Thank you, Rob. And the last thing I want to call out is we've deprecated the max number of dynamic rules and max number of session rules in favor of max number of dynamic and session rules. So this is some consolidation that's happening across browsers on rule management, semantics, and logic. So now this should be consistent across browsers. Again, if you experience any unexpected behavior, please report bugs. We definitely want to make things work everywhere. Another change that is on the horizon is related to the session storage quota. So the session API, the storage API, we introduced this new, in collaboration in the web extension community group, we introduced this new storage area called session, which holds values in memory across the duration of a background context's lifetime. So in Manifest v3, your background context is ephemeral. It will be destroyed when it's no longer needed and started up again when there's work to be done. And for user experience and optimization reasons, you might not want to write everything to storage.local or storage.sync. Those are slower APIs. They take some more time to complete, and therefore they delay the amount of time, or they delay the startup process by taking longer to fetch that data and load it. So the storage session API allows you to hold the value in memory, basically pass it to the browser will hold on to it and give it back JSON serialized objects. When we implemented this in Firefox, we didn't have quota management. We just had the basically exposed the capability without any particular limits on how much data could be stored. But that led to performance issues. So in collaboration in the WCG, we agreed on a 10 megabyte limit, and that change is coming. It's currently enforced in the nightly release of Firefox, and it warns in stable. And the plan is that this is going to land more broadly. The enforcement of that limit is going to land in Firefox 134. So please, if you're using the session storage API, sorry, I wrote it backwards on, storage.session. Please experiment with this change. Make sure that you're staying under quota and provide us feedback. And the last kind of API-facing thing that I want to call out is user scripts. That we've landed support for user scripts. This API, again, was designed in part by Rob and Devlin in collaboration with other folks in the web extension community group. And we think we've got a good API. We think it's ready to go, but we recognize that this will only be totally ready once people experiment with it, test it, tell us how it's working, what's working for them, and what's not. So the current implementation is scheduled to release in Firefox 134, and that was going to be behind a flag, so it's not publicly it's not accessible by default publicly. You can go into settings and turn it on. So your production extension can actually enable this, or in the case of enterprise, you can enable a flag and your users will have this enabled. So again, we'd love to get your feedback on how that implementation is working for you and how that design works. And there are plenty of other things that we're working on that are outside of the scope of just APIs. We are, as I kind of mentioned before, the host permission aspect. Oh, no, wait, that's updated install flow. User consent experience, AMO, or addons.mozilla.org. We have a policy that requires that users provide affirmative consent for any data collection. And that experience is more difficult for developers to implement than we would like, and more difficult for us to verify the implementation than we would like. So we're exploring ways that we can improve this that works better for all parties. And one of the central things that we're keeping in mind there is keeping the user in control of what they're exposing and how the applications that they use get access to their data. We're also taking a look at updating the installation flow for extensions, again, to keep users in control and informed. Host permission controls are definitely part of that, as are just information disclosure and keeping the user in control. And finally, soft blocking. That's for those that aren't familiar. We have the concept of hard blocking, that if a egregious error or egregious issue is identified during a review, we can disable an extension and remove it from user devices. Oh, thank you. We can disable it, and users don't have the option of re-enabling it. It basically says this thing is gone, you can't use it anymore. So this was a thing you had installed and now it doesn't work. Soft blocking is the ability to optionally re-enable it, where a user can choose to say, I understand that you have issues with this. I'm okay with the trade-offs that I'm making in this case. I want to re-enable it. So soft blocking is important for us because it gives us more control over how we approach policy enforcement, and again, giving users more control over their own experience. Now let's talk about a couple of API things. I think I'm pretty low on time, so I'm going to rush through this one a little bit. One of the big changes that we have worked on in collaboration with the Web Extension Community Group is the ability to have a single manifest that can run across all browsers. And one of the main ways that has kind of presented itself is the declaration of your background context. So here is a Firefox or a Safari extension that uses a background page, an event page, in order to run your background script. We can do the same thing in Chrome with a service worker, but notably, we're using two different patterns here. If you tried to have load a service worker in Firefox previously, it would just error and complain. And if you tried to load a scripts version in Chrome, it would error and complain, and neither would load the experience as expected. And the solution we came to is to be permissive and accept both. So across all browsers now, you can declare your background context using both scripts and service worker in the same file. It will run the appropriate execution environment for the given browser, and thereby enable you to have a single set of JavaScript that runs across all of your different contexts. Of course, when using this, you need to be aware that of the limitations of both environments. You can't use DOM APIs in a service worker. This doesn't magically fix that. But there is a set of capabilities in JavaScript that will work everywhere. And if you target that, this enables that kind of development pattern. Another issue that folks have run into with the service worker-based model is that with an event page, we have a scripts array, and you can declare multiple scripts. We'll generate a background page for you and inject all of those scripts. But a service worker is a single key. It's only a string. So if you want to be able to use multiple files in a manifest v3 extension, you can do so by using a loader. So in this pattern, we use the import scripts function, which is only exposed in modules, to import all of these different files and execute them in the background. In this case, I'm wrapping it in a try catch because the way that I tend to work is by using the dev tools as the primary place that I'm interacting with. And if you fail to register a service worker, if your scripts throw on initial execution, then nothing, the service worker isn't registered, so there's no background context to debug. So in order to address that, if you wrap it in a try catch like I do here, an error being thrown in the import process will register a background context that does work. It just doesn't execute any logic, and it gives you an opportunity to actually open developer tools and open the files and figure out where things went wrong. And I think this is the last one. If it's not, then I think I'm out of time. So I'm going to make it the last one. In the background, you might want to load ECMAScript modules or ES modules or JavaScript modules, whatever you want to call them. So in the past, or with the introduction of Manifest v3, one of the capabilities that Chrome introduced was the ability to have a service worker file and specify type module to load that script as a module. That's cool and super flexible, and it's great. So you can do things like import log and then log, we did it. The problem is historically, and Rob actually corrected me a little earlier, I think we now support this. Historically, it wasn't possible to use type module with a scripts array. So we do now. I don't know if Safari does. So this might still be, oh, fantastic. Well, there's no point in talking about this anymore then. So you could load your own page and then manually include your various files as a script type module. Also, HTML is wild, and that shouldn't be a legal document, but it is. You don't need an HTML object. You don't need quotes. It's we shouldn't have this much power. You don't. That's the thing. This works in Firefox. Very quickly, global namespace shim. I lied. I wasn't done. So we're all kind of aligned in the web extension community group about using browser as the global namespace in the future. But Chrome doesn't currently support browser. So to work around that, you can use this kind of pattern to set the global browser variable to Chrome, and then all of your APIs will work as expected. And you can make it even tinier by using global list browser nullish coalescing operator equals Chrome. So this is fancy and cool. What was it? And then if you want to get even fancier, you can have that be alone in its global JS file, and then just drop import global JS at the top of your files, and it will work consistently everywhere as expected. Very cool. And that's it.